All right, guys, so last class we talked about types of chemical bonds and ionic bonding. So remember, ionic bonding happens between a metal and a nonmetal. It is a transfer of electrons instead of a sharing of electrons. And it causes the atoms to have a positive and negative charge. So one atom will give its electrons away. Those are metals. So metals will give its electrons away to get a positive charge. Nonmetals will receive electrons to get a negative charge. Now today we're talking about covalent bonds. So covalent bonds is a sharing of electrons. So instead of transferring electrons like we did last class, remember we would circle the electron and we would draw the arrow. Instead of doing that, we're actually going to be sharing today. So instead of drawing the arrow for transfer, we're going to be circling for sharing. Now, a single covalent bond is made up of two electrons. So a single covalent bond, it's made up of two electrons that are being shared between the two atoms that it's between. Now, one electron is donated to the bond from each atom. So think of it as a puzzle piece. So one electron is going to be donated by one atom, and one electron is going to be donated by the other, and they're both going to share both of those. Covalent bonding occurs between nonmetals only. So remember, nonmetals are on the far right of the periodic table, on the right of that metalloid line, and covalent bonds are nonmetals only. So it's important that you're able to look at a formula and tell me if it's a covalent or ionic bond, because if you look at a formula, you can tell me it's covalent because of the metals and nonmetals, and you can tell me it's covalent because of just nonmetals. Ionic because of the metals and the nonmetals. Now, atoms that are covalently bonded are called molecules or molecular compounds. So atoms that are bonded covalently are molecules. They, anytime you hear molecules or molecular, it means a covalent bond. Now, properties of molecular compounds. Covalent bonds are much weaker than ionic bonds. Ionic bonds have this really, really strong positive and negative charges, whereas covalent bonds are just sharing, so they're going to have a much weaker bond. They have much lower melting and boiling points, is a solid, liquid, or gas at room temperature, and are non-conductors in any state. So they have much lower melting and boiling points, and they're solid, liquid, or gas, and this is because to melt an ionic or a covalent bond, you're actually breaking the intermolecular forces. So say I had two molecules here, okay? So I have two water molecules, that's what these are. What happens is when I say I'm melting ice, what happens is I'm not actually breaking the bonds between the oxygen and the hydrogen. I'm breaking the intermolecular force between this water molecule and that water molecule. And so it's a lot easier to melt ionic bonds because you're actually breaking that intermolecular force instead of a bond, and those intermolecular forces are much weaker than bonds. And we'll talk about intermolecular forces later. Now, the chemical formula for a covalently bonded group of atoms is called a molecular formula. A molecular formula indicates the exact makeup of one molecule. So an example is C6H12O6. So basically, a molecular formula tells us the exact makeup because if we had simplified this, which is the empirical formula, so review over empirical formula. The empirical formula is the smallest whole number ratio of a formula, and ionic compounds are written in their empirical formulas, and that's because ionic compounds is just that repeating pattern of positive and negative ions, okay? So I can just basically if you have 1 sodium to 1 chlorine or 100 sodiums to 100 chlorines, they're going to exhibit the same properties. They're both going to taste like salt. They're both going to act like salt. Whereas here we have glucose. Okay, glucose we eat every day. If you're eating any kind of fruits or vegetables, you're going to be consuming their glucose. Whereas if we simplified this, so greatest common multiple, to CH2O, this is a completely different compound. This is formaldehyde. So formaldehyde is used to preserve dead bodies, and it's actually poisonous to us. So these are two completely different compounds. Even though CH2O is the empirical formula of glucose, CH2O is a completely different compound than glucose, whereas in ionic compounds, that's not how it works. So now what we're going to talk about is we're going to talk about the groups of nonmetals and hydrogen, and basically kind of how we look at their valence electrons. Now remember, we're just doing groups 14 through 17 in hydrogen because this is nonmetals only. Now hydrogen is going to have one valence electron, and instead of saying if it's going to gain or lose electrons, okay, we're not going to say it's gaining or losing electrons because it's not going to become a ion. Basically what we're going to talk about is how many electrons it's short and how many bonds it needs to make. So hydrogen is actually one electron short because remember, hydrogen only needs 2 electrons in its valence shell to have a full valence shell. And so what's going to happen is hydrogen is going to make one bond to fill its valence shell. Now group 14 elements, so group 14 elements, nonmetals would be carbon and silicon. They have 4 valence electrons, which means they are 4 electrons from 8, because remember the magic number is 8 except for hydrogen. Hydrogen only needs 2 electrons. And so group 14 have 4 valence electrons. It's 4 electrons short, and so in order to get those 4 electrons, it's going to form 4 bonds. Group 15 has 5 valence electrons, which means they are 3 short from 8, so it's going to form 3 bonds. Group 16 has 6 valence electrons, which means that it's 2 from 8, and so it's going to form 2 bonds. And then group 17 have 7 valence electrons, it's 1 from 8, so it's going to form 1 bond. And so we're going to be using how many bonds it needs to form and how many valence electrons it has to write these molecular compound structures. All right, so it says write the dot and structural formula for H2. So first is the rough work. This is the copy, basically your work. So H2, we have 2 hydrogens. Now, we need to know how many valence electrons hydrogen has and how many bonds it needs to make, okay? So hydrogen has 1 valence electron and it needs to make 1 bond. So that means each hydrogen is going to have 1 valence electron and it needs to make 1 bond. So this is how you're going to make the bond. So remember, instead of doing the transfer of electrons like we did in ionic compounds, we're actually going to be sharing electrons. So each hydrogen needs to make 1 bond, and it's going to make that 1 bond with each other. And so we're going to circle where that bond is made. Now, bonds are always made. Bonds are always made with single electrons, okay? So that means that in a second you're going to learn what an unshared pair is, but basically a single electron is just 1 electron on one side of a Lewis structure. So the Lewis structural formula, what we're going to do is we're actually going to replace those dots with a line. So in the Lewis structural formula, we're going to put a line between the 2 hydrogens, and what that line means is that 2 electrons are being shared. Okay, 2 electrons are being shared. So each line means 2 electrons are being shared. Now this is called a single bond. Okay, that's called a single bond. That means a shared pair of 2 electrons. Now let's look at this next example. We have O2, so we need to determine the valence electrons and bonds it needs to make. So oxygen has 6 valence electrons and it needs to make 2 bonds. Now this 2 here means that I have 2 oxygens. Okay, so anytime it has that subscript, make sure you draw that many elements, or that many of that element. So we have 2 oxygens. Now oxygen is going to have 6 valence electrons. So remember, when drawing your Lewis structure, each side has to get 2 before any, or each side has to get 1 before any side can get 2. So I drew 4 around oxygen. Now I'm going to be bonding with this oxygen. So I want my single electrons, meaning my electrons that are by themselves, to be facing that way. So I'm going to put my double electrons, which you're going to learn in a second is called an unshared pair, on the top and the side where it is away from the bonding. And I'm going to do the same with this oxygen. So I'm going to put them on the top and the side away from the bonding. So the bonding actually happens where there are single electrons. So you see how these electrons are not paired? That's where the bonding is going to happen. But also notice what I did there. I shared the single electrons here. That was easy to see, but each oxygen still had a single electron to bond, and so I did a second bond there. And you can do that. You can have more than one type of bond or more than one bond between two elements. So my Lewis structural formula, so remember one line means 2 electrons are shared, but here we see that 4 electrons are shared. So I'm going to put 2 lines because those 2 lines tell me that 4 electrons are shared. And this is called a double bond. So it's 2 shared pairs of 4 electrons. Now again, I want to point out the unshared pair. So an unshared pair, okay, so an unshared pair of electrons is basically a pair of electrons that is not participating in bonding, okay? Now unshared pair are going to be very important next class because they are going to determine, especially on the central atom, the atom in the middle, it's going to determine the shape of the molecule. Now here we have N2, okay, so we need to determine the valence electrons and the number of bonds. Nitrogen has 5 valence electrons, and so it needs to make 3 bonds to get 8. So again, if you're not sure, you take the number of valence electrons, so you take the number of valence electrons and subtract that from 8, and that's going to give you the number of bonds. Now, our rough copy, again, we have 2 nitrogens. Now, each nitrogen is going to have 5 valence electrons. So again, I'm going to put 4, each side's going to get 1 electron. Now, I'm going to put that unshared pair on the outside of nitrogen because I know that my bonds are going to occur with these single electrons. So I want those facing the other nitrogen that it's going to bond with. And so again here, I'm going to draw 4 valence electrons and then put that 5th one on the other side. Okay, so we see a bond is going to be formed here. And then we see that a bond is going to be formed here. But notice both nitrogens have not had 3 bonds. They both had 2, so we're actually going to form a 3rd bond here. Okay, and so nitrogens are forming 3 bonds between themselves. And so we're going to put 3 lines between the 2 nitrogens because they needed to form 3 bonds each. Now, this is called a triple bond. Okay, so this is when there are 3 shared pairs of 6 electrons, a triple bond. You will not go above a triple bond. It will stop at a triple bond. All right, next one, H2O. Now we have 2 different elements in a compound. We have 2 hydrogens and 1 oxygen. So we need to determine the valence electrons and the number of bonds for each. So hydrogen has 1 valence electron and needs to make 1 bond. Oxygen has 6 valence electrons and it needs to make 2. So again, the number of valence electrons come from that group number. We see that oxygen is in group 16, so it's going to have 6 valence electrons. So here's my rough work. Now, there's a question I have here. I have 2 hydrogens and 1 oxygen. That's what that H2 means. So one of these is actually going to have to go in the middle, and it does matter which one goes in the middle. Now, because we could have several different shufflings of this. We can have HO or HOH or OHH. You know, we can have several different compounds made from H2O. And so to determine which one goes in the middle, we're going to put the atom in the middle that wants to make the most bonds. So we look here and see that oxygen wants to make 2 bonds and hydrogen only wants to make 1. So we're going to put oxygen in the middle. And then we're going to put hydrogen around it. Okay? So put 1 hydrogen on the side and 1 on the bottom. If I had 3, I would put 1 on the other side. And if I had 4, I put 1 on the top. But in this case, I only have 2 hydrogens, okay? So oxygen's going to have 6 valence electrons. So I'm going to draw these 6, okay? I'm actually going to move this one closer to oxygen, okay? And then hydrogen each has 1. Now notice with this hydrogen, I put that 1 on top because I noticed that it's going to form with the single bond, so single electrons. So remember that the bonds form with those single electrons. And so I put the valence electron for this hydrogen on top so that bond can form here. And then we're going to form another bond here. Okay? Now, oxygen has formed 2 bonds. each hydrogen has formed one. So we have finished our structure. So now for the Lewis structural formula, I'm going to draw the oxygen with 2 hydrogens on either side of that oxygen. So we have 2 single bonds within water. Now the next one is O and F. So we have 3 different elements here. So we're going to determine the valence electrons and the bonds. Oxygen has 6 valence electrons, so it needs to make 2 bonds. Nitrogen has 5 valence electrons, so it needs to make 3. Fluorine has 7, and so it needs to make 1. Now again, we've got to determine which of these elements is going to go in the middle, and that's the one that needs to make the most bonds. And I see here that nitrogen has 5 valence electrons and needs to make 3 bonds, so nitrogen is going to be the one to go in the middle. Now it doesn't matter which side you put the oxygen on or which side you put the fluorine on, as long as nitrogen is in the middle. So again, nitrogen is going to have 5 valence electrons, fluorine is going to have 7, and then oxygen is going to have 6. Okay. Now, I'm going to make the first bond with the element that needs to make the least number of bonds. Fluorine only needs 1 bond, so it's going to be easy to kind of get that bond out of the way. Okay, so nitrogen is going to make that 1 bond with fluorine. Now I'm going to move on to the oxygen because it only needs to make 2 bonds. So it's going to make 1 here, and notice that each oxygen and nitrogen still have 1 more electron to form a bond. So a bond is going to be formed there. So for the Lewis structural formula, you'll have oxygen here. Now notice what this is. It's a double bond. They're sharing 4 electrons. So I got to draw 2 lines there. Then nitrogen is in the middle, and then a single bond to fluorine. And so that is what our structure is going to look like. Now next class, what we're going to look at is we're going to look at molecular geometry, which means the actual shapes of molecules. And these molecules actually have different shapes because of the electrons repelling each other. So the electrons in the bonds and the lone electrons on the central atom will repel each other, causing them to have a shape.